This is going to be a quick tutorial on showing you how to use any DIY laser engraver cutter with a program called GRBL laser engraver. And it uses a raster to G-code conversion, and also it's a sender to send the G-code directly to your printer to burn images into wood or some other material that your laser engraver has the capability of burning into. This DIY is using all freeware open source software. Quick note to add here is that using this program LaserGRBL to print onto wood, an image onto wood, your laser absolutely needs to be PWM controllable, pulse width modulation. Most people using these 3DP printers, I'm assuming, are using a PWM controllable laser. Without it, you will not be able to burn images. This is a laser that may just turn on and off and only be able to burn at one power. This will not be able to burn images onto wood. I have a couple tabs open on Chrome to show you some different things. To do my image editing, I'm going to be converting an image from my cell phone to black and white and burning it onto a piece of MDF using a program called Inkscape. So you can just head over to inkscape.org and download it. It's cross-platform. The LaserGRBL software, I'm pretty sure on its homepage, it labels it as a Windows program. So I think this only works on Windows. I did not design this. I just found it, and it works with the 3DP burners and with small DIY, relatively low power, but it still gives you some pretty good support and adjustments for your settings. So, and it burns pretty decent images. So, anyways, it's called LaserGRBL. So if you go to lasergbl.com and go to download, you can download it. It's only available at GitHub. When you click on this GitHub link, it'll bring you to a page that looks like this. Most people are familiar with GitHub. Apparently there's a German translation if you want it. Otherwise, you can go down here and hit the setup.exe. That will download a file that looks like this. I've already pre-installed it on my computer. The software is open, but we don't need it just yet. So I guess the first thing we need to do is open up Inkscape and navigate to our image. So if you go to File, Open, I'm going to pick an image from my cell phone that I put on the computer. Open it. I don't mess with any of these default settings, so just click OK. This pane might not be here. If it is, don't worry about it. We're going to be opening it up later. My computer takes a minute because it doesn't have a lot of processing power. Anyways, here's my image. So the first thing that we're going to do is, I guess we can either crop it first or change it to black and white. Let's crop it first. The way you do that in Inkscape is you select a tool that has an object, so this rectangle will work, and you can select your image. Yours, disregard what I'm doing at this very moment. I will redo it. Your object will probably have a shape that's square when you first click and drag. If it doesn't, I can show you how to do that here in a moment. Your object might be a different color. It might be similar or have an outline. If you go to Object, Fill and Stroke, I guess I need to close this one. Fill and Strokes behind it. Fill is the fill, so a color fill, and these are your colors you can choose from. It might be over here. I like the wheel because it's easy to use. You can drag this to a color, so I just have it on white. And then here is your opacity. So this is, almost see-through. Your color might be totally solid, but you can adjust this down. I just like it so I can see the image behind it, and I can also see the image in the front. That's what you're shooting for. So you can resize this if you click on the selection tool. I lied. So to get back to the square tool on this object, you can use the selection tool and double click. So if you hover over this corner, it highlights the corner. These two corners are for resizing this object, so you can resize it down. This one, when you drag down this way and this one over this way, that adds curves. So I'm going to resize this to just kind of be a little bit smaller here. And then if you use the selection tool, you can either click and drag and move this, or you can do fine-tune adjustments with your keyboard keys. That's pretty centered, looks good. So if you have the selection tool and you double click on the object, then it'll bring you to this object view here, and you can see the circular point right here. If you click and drag down, this does your vertical curvature on the corners, and then you can come this way and do your horizontal curvature. I guess it's not super necessary. I guess you could have just done a circle, but we'll just call that good. You don't even need to do this if you don't want to, but I'm just trying just not to have a square picture. I just have cut off corners. Okay, so in order to crop this, what you want to do, we have this object selected. We have to select the background image. So you click on the selection tool, hold down Shift, and click on the background image. Now you can see this dotted line here, and the foreground object is selected. So if you hit Object, Clip, and Set, then that pulls it crops the image to the new object here. And then I'm going to go to Filters. With this object selected, it's the only object, but it's selected. Color and Grayscale. And if you hit Live Preview, it'll show you a live preview of what you're doing. I'm going to keep it there. You could mess with different things here to change the lightness and darkness. That's actually kind of necessary, but I'm going to do it in the LaserGRBL program because you can do it there as well. And hit Apply. So that's done. Click the X. And then if I click on the selection tool and click on the image, I can think better in terms of millimeters. So I'm going to click on millimeters here. And this is 383 pixels by 385 pixels. It's kind of big for a quick burn tutorial. So I'm going to lock this. So it's locking the X and Y dimensions. So if I change the width or the height, it'll change the other one accordingly and not skew my image. I'm going to make this, I don't know, 50 millimeters for the width. Hit Tab. That'll make the height accordingly. So I almost made a square. You can zoom in using this small tool here to go in and out. If you're using a mouse, you can hold down the Control and scroll wheel to zoom in and out. Alternatively, there's View, Zoom, Selection here, which will pull the selection into view. So that's my image. And to export this so we can use it with our laser engraver, you go to File, Export PNG Image, and make sure that you have selection selected here so it's exporting the correct image, the thing that we have selected. So the width is 177.165 and the height is 178.139. I made this about 50 by 50, so I'm just going to remember that. It's about 50 by 50 millimeters. You have to select a path. So if you go here, I just made a quick desktop folder called 3DP Picture Burning Project. And I'll just call this Test. Save. That didn't actually export it. You have to hit the export button. And that happened fast. It exported, so we're good to go. So I'm going to put this on the down bar. Once you download and install your LaserGRBL program, it'll be in the Start menu probably. I'm using Windows 10. It's here. So if you open it, I already have it open down here. You don't have to connect right away. You could if you wanted to. I'll do that in a minute. I do have the USB plugged in from the GRBL shield with Arduino, but my unit is not plugged in. Hit File, Open File, and then navigate to the path where you just exported your picture. So 3DP Burner Project folder, and I'll click Test and Open. This is my image, and I'm going to burn that onto the wood. I kept most of this on its default settings. I did change a couple things. If you adjust the brightness, I've kind of learned that you kind of have to go a little brighter than you think for the image to not be too dark. I'm pretty new to this, so there might be some other settings. Anyone who knows a lot about it can just pipe in with whatever they want. You want to increase the contrast between your highs and lows to help define the image clarity a little better. So I'll go there, but I'll make the brightness higher. Okay. And there's different ways to do the conversion, but line-to-line tracing is where your laser engraver is going to be going from line to line. So that's the way it's set up by default. We already have a black and white image, so we don't need to convert it. I think that's what this would do here, but we did that in Inkscape. Also, your direction, I think it's on horizontal to begin with. That literally means it's going to print going horizontally line to line or vertically line to line. If you go diagonally, I've done some research and talked to some people. I guess it might make a clearer image, but that also depends on what you're burning into. If you have a nice homogeneous material like MDF that burns the same no matter which direction you cut it or engrave or burn, then you can use diagonal. But if you're going into a nice grain of wood, you kind of want to burn with the grain. So depending how you orient the wood, you want to select the proper horizontal or vertical here. I'm just going to go ahead with diagonal. Two other quick notes that might be beneficial to someone and save you some hassle is if you're going to burn an image into wood and you want to put some kind of material like a stain or beeswax or mineral oil that's going to protect and make a nice shine to the wood, you want to do that before your burn because it will swell the wood and warp your image. So people put lacquers on the outside of their or like a like a top coat, clear coat on their wood. You can do that afterwards, definitely, but if you're doing any stains or mineral oil, beeswax, do those first before your burn. And burn with the grain, not against the grain or diagonal to the grain. Makes a better image. Down here, you can rotate the image if you needed to I don't know, if your machine's not square, you might want a landscaped image to fit better on your machine, so you might turn it. You can also flip the image horizontally, vertically, or crop. We don't need that, so I'll hit next. These settings are perfectly set up for the LaserGRBL 3DP burners as they're bootloaded. So the laser on command is M3. You could, if your machine had laser on as M4, change it to M4. Laser off M5, which ours is. I think that might be the only setting. Looks like there's information there. But yeah, anyways, that's all it has. Engraving speed is the speed that this software is going to generate code for while it's burning any kind of coloration. So it's going to go at 1000 millimeters per minute while it's doing any kind of color or any kind of grayscale. And if it's going over a totally white spot, like maybe this part of the image, then it's going to move at 4000 millimeters per minute. So the way that you actually get a varying scale is it pulse width modulates your laser. So your laser also needs to be PWM controllable, or else you can't burn an image. You can kind of only burn solid color. But so if your laser is PWM, like most people that use the 3DP burners are, then this will work. Your S minimum is your minimum burn command, or your 0 PWM for no burning, and your S max is 255 for max burn. If you have a really powerful laser, you either need to increase your speed, but you can only go so fast with these machines, so you might need to limit your max power so that you don't burn the image too much. Like if you're getting too dark of an image, you can just change your max to be lower, maybe half or a third or whatever you need to play with it anyways and make your image lighter. You could also start out by having a brighter image, so there's quite a few things you can play with. But also the size of the image was in there from the last thing I was doing. I know that the image is 50 by 50 roughly. And then the offset. So this machine, I have something pulled open to show you. With the 3DP burner machines, they have a y-axis here and an x-axis an x-axis end stop and a y-axis end stop. The home position will be with the carriage moved over this way, and on this x equals 0 would be kind of here, and y equals 0 end stop anyways would be here. But this code is generated to start printing from this corner. So the side of the machine where the X end stop is an opposite of the Y end stop. So if you want to print somewhere else, you need to tell it an offset. That is what this is here. So the offset 5 and 5 for me is going to kind of start printing in this general vicinity, 5 millimeters in on the X and 5 millimeters up on the Y. So you don't need an offset, but if you create one, you can move wherever you want on the machine and start printing wherever you want. So you hit create and it runs the code, and once it's done, it'll open up the image and show it in red. So that's here, and it kind of shows you the start position is with the offset. So it's a 50 millimeter by 50 millimeter image. So it's going to start at 5 and 5 and print 55 up and 55 over. I'm going to connect because plug in your USB and you can connect here. You might have to change your COM port, but I think baud of 115/200 is what you need. It recognizes the 3DP burner and throws up a little message here that it found it. And yeah, anyways, I guess I didn't click that right. So it found the 3DP burner. If you hover over this, it now says disconnect, so I'm connected. I'm going to plug in the machine because the fan was running and it's a little noisy. Okay. Make sure that you hit the home before you start the print. I have tested this before and it rams into one of the edges. It needs to know where home is, so make sure you hit home before you start. And the only other thing you need to do, I guess I can show you. I haven't played with all the settings, but you can hover over them to see what they are. But GRBL reset, something about locking the GRBL. Once you start, you can stop with this button. And I don't know what this is, but there's a status symbol here that's telling you what it's doing. So the machine's on, it's connected, but it's in idle, it's not burning. So I'll put my glasses on, protect my eyeballs, and I'm going to go ahead and hit the play button. So the laser's navigated over into this corner, the corner I showed you, here-ish, and it started the burn. And back on the software, you may be able to see there's a small crosshair moving back and forth. This is showing you the actual burn position of the laser as it goes. Progress bar tells you in seconds and minutes how long it's been running. And down here, the projected time for the print is 26 minutes. So that's here. I guess I didn't show you this. It's kind of bad, but when you open up your image, one of the settings when you're doing your conversion creating the G-code is it asks you how many lines per millimeter if you're using the line-to-line code tool or code setting, how many lines per millimeter you want. Depending on your focus of your laser, if you have a really tight beam, you might want to increase it from the default. The default's at 3, you can move it up to something like 7, and it'll make it so that when your print comes out, you don't have little lines, gaps where you don't have any burn, and it'll just make a nicer image. A large image that I burnt earlier definitely has visible lines that aren't burnt in it that you can't really see from a distance of a couple feet away, but under close inspection you can definitely see gaps. It'll be something that you have to play with, you know. I'm using a 2-watt laser on this device, and it burns a really dark image at the default 1000 millimeters per minute. And it seems like the machine's a little jerky because it's not accelerating and decelerating between changing from white space, a different speed, to a 1000 millimeter per minute burn area. But anyways, I'm going to click over to my phone and do some recording so I can show you that and not waste your time with this part of the print, and I'll come back when it's done. Okay, the print is nearly done. You can see that it looks like it has changed from, I think, 26 minutes down to 22, so I guess that doesn't stay static. And the progress is 21 minutes. When the print is done, it does home back to the homing buttons, and I will take a quick video to show you the finished product and splice it in here. So right now you can see I'm burning in the back left hand corner, and I guess I'll come back to it when the burn's done, but it's just going back and forth and using PWM control to pulse width modulate the power, but it's using the same speed during any burn pixels, and just changing the power momentarily to either make it lighter or darker. So as you can see here on my machine, I'm in the it's printing near the X end stop, but opposite of my Y end stop, and it's in my area that's a 5mm by 5mm offset, and you can see the images starting there. On the computer you can see where it's jogging back and forth, maybe there, printing and scanning there. And it looks like I have 23 minutes total of 4 minutes in, so it still has a minute. I'll come back to this when it's done. Okay, the print just finished right at 22 minutes, and it actually homes down to the original printing side of the X equals 5, Y equals 5. You actually have to hit the home button, which I'm going to do now, to bring your 3DP printer back to the Y home. It's at the X home, but now it's at the Y home. I'm going to disconnect and close this. And unplug my machine, and I'll show you the end product. Okay, as you can see here, the print is done. It's 50 by 50 millimeters. It took about 22 to 25, 26 minutes to print. It's pretty black. The white of the right eye is totally not visible. I probably have to play with the contrast a little bit. I also took a very large image and shrunk it down, so it's kind of granular. It wouldn't be so granular looking, kind of crappy looking, if I didn't shrink such a large image down. To to begin with, but I just wanted to do a quick tutorial. Although it's a pretty good image for just throwing something together pretty quick. I also printed something much larger, the same image but not as cropped, earlier, and it took about 3 hours and 10 minutes to print. On the image I just finished burning, I did 7 lines per millimeter as the setting. This one I did 3 lines per millimeter, and you could definitely see some lines going on in there. So my beam width is a little bit tighter than the 3 lines per millimeter. So you end up getting a little bit of gapping going on. I guess if I increase the number of lines per millimeter, it probably would have significantly increased the length of burn time. So this is like a 400 and something wide, I think, by 300 and something long. So yeah, anyways, I routed the edge of it, and there's a soft spot on the side of the MDF where the board was smacked down, and it didn't like that with the router, but whatever. This is just a test. But anyways, yeah, use your 3D printer to burn images using the software. I also have not tried the image to G-code software yet. I will give that a try. This is the first one I tried, and I'm just making a quick tutorial to show you how to do it. So yeah, share whatever you burn. And if you find any good settings that make burning clearer, better images, you know, or any quick tips, go ahead and share them, and everyone will benefit from it. So, all right, hope you guys enjoyed.